Hey everybody, this is Alex Merced from alexmercedcoder.com, and welcome to this third video on using Docker. So in the first video we talked about how to just basically use Docker, how to run a container and shut off a container and see what containers and images you have. In the second video we talked about how to create your own container using a Docker file and sort of the concepts behind that. In this third video, we're going to talk about Docker Compose. What Docker Compose does allows you to say, hey, I have multiple containers that I want to run at the same time that do different things, but I want them to see each other. Because I could just manually run a bunch of containers, but then trying to get them to all talk to each other gets a little complicated because they're all isolated. What this does, it kind of creates a network. So I can create many services. So what you do is you create a file called dockercompose.yaml. Okay, and what that's going to do is say, hey, I can run this file and it's going to create the environment that I specify here. So generally you always start off with like this key of services. This is written in Yaml, which is a language that's used for different configuration. You might have used it for different things, like if you've used like Rails or there's a lot of places that use Yaml, so you've probably seen this at some point. But essentially, think of it as this: think of this as like a object, and then anything tabbed under it is a property of that object, and so forth. So this is a property of the Python. So services is going to have all our different services. Python, we can call it whatever we want. So I'm calling it Python because this is the container we just made in the previous video that really just has Python installed. And I'm saying, hey, for this service, I want you to use this image. Okay? You could also build it from a Docker file. So I could have done build and then specified this Docker file. But I'm going to say, hey, this image, and I want you to expose ports. Okay, there's certain ports on that container I'd like you to expose. So we'll say, hey, I want 5,000. And then I can map it to 5,000. Say, hey, map the 5,000 in that container to the 5,000 on my computer. Map 3,000 to 3,000 on my computer. Map 8,000. And again, if you've used Python and different web frameworks, you probably notice that these are generally the ports you see often used for your development servers. So I'm saying, hey, you know what? I want you to map these ports so that way, hey, if I run that server in this Python environment, I'll be able to see it in my web browser. Okay, cool. So that's one service. But let's say, you know what? I wanted to practice using Python with like Neo4j. So I might create another service here, Neo4j. Okay, and that's the name of the service. And then what I'll do is I'll go look up the Neo4j container, which we see here. So I'll sit there and say, hey, you know what? I want to run the Neo4j container. Neo4j, that's the name. Again, I can just use the name of the container of the image from Docker, basically whatever I would put after Docker pull. So that's the container I'm going to use. And then I'm going to want to expose some ports. Okay, so I can read the documentation and say, okay, what does it want me to do? Okay, so it wants me to expose these ports. Okay, so I'll expose those ports. Okay, and the thing is that the exposing the ports only exposes it to my computer, like my main non-Docker image container computer. By default, these will be able to see each other. Okay, so essentially what's going to happen is that, like, when I'm writing, like, let's say the app on the Python container, since this service is called Neo4j, it would be able to access the database from like http://neo4j/ and then what's the port for Neo4j again? 7474 or port 7474. That's where that server would be. So these service names become their relative hosts to each other. Okay, and that's how they can then talk to each other within the scripts inside of it. So that's something to keep in mind. What was I looking for? Oh yeah, we're talking about this. Okay, and then here you're just mapping a volume for somewhere to save the data, but that's fine for now. Okay, and then here we have an environmental variable that we need to do for the auth. But first, let's just do the ports. So I'm going to expose the two ports and say 74747474. 7687. 7687. Okay. And then, again, I can create any environmental variables, which that I want to say it's the key is environment, but let me just double check. Docker compose environmental variables. Docker compose environment variables. There's two ways of doing it. You can actually specify an environmental variable file, or you can actually specify the variables in there. So image, man, that's all fun and good. And how about that's if you want to do a file. Well, there you're specifying the file out when you run the command. It's all fun and good. Here we go. Okay, yeah, it is environment. I thought that's what it was, but always like to make sure. Environment. And then here I can specify any environmental variables that I want to have defined. So when I read the documentation here for the Neo4j container, it says, hey, you know what? You may want to define this env variable, or define this variable Neo4j auth, make it equal none. So I'll just do that. Neo4j, and doesn't need to be a string. Let me just take a look back over here. No, it doesn't need to be a string. So Neo4j, and that's all uppercase. Neo4j underscore auth equals none. Okay. And it is saying, hey, he wants it as a string, so I will give it to it as a string then. Okay. Let's see here. Debug. Okay. Node environment infile. You know, I do think I have to pass it as a string. Okay. But essentially that would be it. Okay, now these files, I could also do things like specify volumes. Again, volumes are me saying, hey, this file folder on my computer maps to this folder in the container. I can override entry points. I can do all sorts of fun stuff. Okay, but now all I have to do is just do docker compose up. And with docker compose up, by default, it'll look for a file in the folder that you're in called docker compose.yaml. You could use another name, but again, you'd have to pass a flag saying, hey, use this file instead. But docker compose up will just look at this file and begin spinning up these two containers. Okay, and see it names the network after the name of the folder, so it's called Rails 101. But see, but it's right now it's downloading the containers, the Neo4j container, because that's not installed yet. And so I'm going to open up these two containers. They'll be able to communicate with each other. Again, they'll be on the same network. So I can go inside the Python container and then like use the Neo4j database in the other container as my database. But they're both in their own isolated containers. So you allows you to create this environment of all these isolated pieces that build your app, which is really nice. You could just try to build it all on one computer, one image, but then it's not really isolated. Then you have to worry about like compatibility issues. You know, if you install this first, install that second. Here you can kind of have them as like separate. And again, separate containers are like separate computers that can see each other on a network. And you can just write it up as these Docker Compose files, which you can see here aren't that hard to write. And it says, cannot create container for service invalid port specification 74. Oh, wait, did I put too many numbers in that? I think I put too many numbers. I did. 7474. There we go. Yeah, you can't go to 74,000. The highest port number is 65,000 something something. And the reason for that is because that number, that port number is a was it 16-bit integer? And the highest number that can be fit, actually more than an 8-bit integer. Well, whatever size integer it is, the biggest number you can put in there is a 65,000 some change. And that's the reason why. So it's not like, hey, this is like how many ports. We want you to use 65,000 ports. It's just that the port number is really just a label that is represented by that data type, and the maximum value for that data type is 65,000. Okay. So Rails 101 Python 1 exited with code 0. So that means it was some other issue touching Rails. Okay, so I'm just going to open up another terminal. And I'm going to say here, Docker container ps. I see are both containers running. Docker container ps. And I see the Neo4j container is open, but looks like the Python one closed. Okay, which is fine. The Neo4j one can stay open. What I can do is, it must have closed because it's expecting me to do something. So what I can do is I can then just run it again separately. And then I can just do Docker compose run. And since that service was called Python, again, when I say Docker compose run Python, it's not going to look for a container named Python. It's going to look in the Docker compose, see that there's a service called Python, and look for the container, whether a container was created based on that Docker compose file, and then turn that back on, or create a new container if one isn't created. So then I can say, hey, Docker run Python, and then say, hey, let's open up bash in there. Bin bash. Okay, you can see now I'm inside that container. And I should be able to curl the other container. So I'll do curl. Curl allows me to do a request. I'm going to say, hey, I want to curl HTTP // which the other one's just called Neo4j, right? Neo4j HTTP Neo4j Neo4j 7474. And just, I should get some sort of error back, but it shouldn't be like a 404. Okay, and see I got something back. Bolt routing. So see, it sees that other container is running. Because see, I'm getting some Neo4j stuff back. Okay, which is just telling me what the endpoints are. Okay, for that Neo4j server. So even though there's two separate containers, there's the Neo4j container and there is my Python container, they can see each other, they can communicate each other, because since they're in the same Docker compose file, they're part of the same network. So that's what Docker compose allows us to do. It allows us to kind of orchestrate many containers as a network of pieces that are working together. Again, so that way I can have like a separate container for my database, separate container for my app, a separate container maybe for a Redis database, for in-memory management, so forth and so forth and so forth. You can replicate an environment by just literally running Docker compose op. But now when I'm done with this, so I'm going to exit this. And hey, I don't want to run this anymore. I can just do Docker compose down. And then that's going to Docker dash compose down. And that's going to stop any containers that are still running in that network. So as you can see, like, there's different layers to how you can use Docker. There's just, hey, I can go use a container that's already created out there to do some work. I can create my own container to create my own environment. I can orchestrate my environment from many containers using Docker Compose. Okay, and then you can even further like automate all that using like Kubernetes, something like a Kubernetes, where you can sit there and say, where you can, say, hey, we need another instance of this container, so go spin this up when the traffic's like this, and that's a whole other conversation, a whole other thing that I actually haven't really dabbled with yet. But hopefully you guys enjoyed that walk down. Again, this wasn't supposed to be a comprehensive Docker lesson, but the idea was to kind of just give you a better idea of how these pieces fit and work together, so that way you can start exploring and playing around with Docker and realizing it's not scary. It can be a lot of fun actually, but do keep in mind that you make sure you don't hoard containers and fill up your hard drive too quick. But with that, I'll see you all later on. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.